Hello, and welcome to the Windy Synth. Today, we'll be continuing the series on the Windy One synthesizer project. Today, we're going to go through the code. The Windy One synthesizer emulates the EW4000 sounds. The first thing I'll do is go through the block diagram of the EW4000. And then, we'll look at the Teensy Audio Library diagram for the Windy One synthesizer. And then I'll briefly go through the code to show you how it's all hooked up. Here is the EW4000 block diagram. The EW4000 has two oscillators followed by two filters. There's showing one filter here, but there's actually two. You can see the switch between 1 and 2 there. And then there's a format filter. I don't have the format filter implemented yet on the Windy One synthesizer. And then there's an amplifier, and it goes through the effects and then out. There's a noise generator, and then the same kind of filters as the oscillator filters. There's two filters and then mixed in, and then that goes to the effects. The common block here, you can set the signal to re-trigger every time you play a note. And then you have the pitch bend range, and you can set the pitch bend to change in semitones. That's what this step button is. When you play the EW4000, you can play up to 2 notes at a time, and this octave button level sets what the other note level is. The Windy One synthesizer doesn't implement the octave level button here because you can only play 1 note at a time. Here's the audio system design tool for the Teensy Audio Library. This is the entire block diagram for the Windy One synthesizer, which mimics pretty much that other block diagram I had here. It's pretty much the same. It covers the same information. And I'll walk you through a little bit of this. The way this works is each of these blocks, you click on them here, and they describe on the side here how to use the block. Like this is a mixer block, and it has 4 inputs and an output, and you can hook the signals up. And then this is a DC block, which allows you to set parameters and send the signal, a constant signal here, or you can cause it to ramp by a number of milliseconds with these function calls that you call within the code. This is sort of the way this is all wired up. The oscillators themselves are this block here. In the oscillators section, there's a saw wave, a triangle wave, and a pulse wave. And the pulse wave can be varied. So you had to use 3 different oscillators and then mix them together here. And then here's the second oscillator here with its 3. They get mixed together. And then there's various controls here to set the way these get mixed together and the levels that happen based on your breath. See, this DC controller, when you breathe into the EWI, it sends the MIDI message over to the synth, and then that breath signal gets put here, and then that gets mixed in here with the, I'll talk about this one in a second, but anyway, you get the basic signal gets amplified here and then mixed together and moved to the next level. There's 2 oscillators, and the EW5000 has this crossfade, and you can, so that when one of the levels meets the threshold, it starts to steal signal from the other one, kind of, and so it fades between them with this crossfade if you have this X-FADE turned on. And the way I did that was with this mixer here and these 2 signals. So the signal comes in, and the values are calculated whether they're crossing the threshold and whatnot, and mixed together, and then that amplifies the signal coming through for the 2 oscillators. The other things that drive the oscillators is the sweep signal here. There's the sweep time and the depth and the breath attain, and these affect the pitch of the oscillators. When you trigger the sound, this one sweeps by time by a certain amount of depth toward the note that you have. It either sweeps, if you have the depth negative, it sweeps from the below, and it'll sweep from above if you have the depth higher, and then the time is here. and that's that way. You can do that with the breath. It'll reach, when you breathe as hard as you can, then it'll reach the note, and then it'll start either lower or higher depending on where you have this depth set. And then you can set the attain. So how much breath do you need to blow to attain the actual note you're trying to get. This is a real subtle effect because it doesn't pull this depth. It doesn't pull the pitch off that far, although you do notice it. And then the threshold, like I said before, it was the threshold for and then there's a curve. The threshold is for the breath. When does the breath start to kick in? You can set the threshold on how hard you have to blow before this output starts to go. And then this curve is basically sets the curve. So you can look at the manual how this all works. But that's all implemented in here by these various modules. And so those are the oscillators, and the oscillators get mixed together, and then they come down here to the filter. The output comes to the filter, and then it also comes to the mixer directly, because this filter has a low pass, a high pass, and a band pass, but it doesn't have the notch. So you have to subtract out the band pass to get the notch signal. As well as if you want to turn the filter off, you can come through and bypass it and set the mixer up that way. That's how I implemented that. And then the controls for the filter are all in here. There's a low frequency oscillator, and there's some control from the breath that you can put on the low frequency oscillator, as well as the breath controls gets mixed in here. And all of these signals get mixed together to drive the filter. When you look at the filter, one of the inputs is the frequency control of the filter. So that's where the cutoff frequency is. And then the mode of the filter is done by it's got 3 outputs. And so you can mix them, like I said before. So there's 2 filters, and they're identical in the way they're hooked together like that. And then there's this is the format filter. I don't have, it's just passing through right now, but this is where the format filter will be put eventually. And then there's the noise generator. We put a noise source here, pink noise. And then there's some filtering. I tried to filter the noise to make it sound a lot like, as much as I could to make it sound like the EWI 4000, but I could listen to it and look at it on a scope and try and get the levels right and stuff, and didn't really have any, I don't have a really good spectrum analyzer to look at it and to compare and see, what's going on there. But anyway, I think I got it pretty close. There's the controls of the noise generator. There's a time control and a breath control and a level, and then that feeds the filter. And so those are set through these blocks here. This is a multiplier block here, basically, and I'm taking the input, the signal here, and running it to both inputs, so that basically squares the signal. And what that does is, as this ramps, it would normally ramp linearly, and since you're squaring it, it puts a curve on it that makes it sound more like the 4000 did. The noise signal goes through its filters, same way that the other filters work. And then everything is mixed together. And there's some additional filtering to match some of the... there's some static filtering that is in the 4000 that seemed to be there. It seemed to be like a high-pass filter on the signal. So I put that in there to mimic that. That seemed to always be there. Then the chorus section. So in the block diagram here, there's a chorus section here. Let's see if I can show you that. So here's the chorus, the way the chorus effects work for the 4000. You can see the signal comes in here. There's a dry level, and then the signal comes in, and there's 2 paths. There's going through delay 1 and delay 2, and then there's an LFO that modulates the amount of delay, and then you can mix in how much you're putting of that signal in. And then there's a feedback signal you can select and how much feedback goes in, and then it mixes with the dry and goes out. So in order to accomplish that, there's a chorus module in here you can use, but it doesn't allow you to modulate the delay. It allows you to mix different delays together, but it doesn't allow you to modulate delay. So if you look at this chorus that they have, it doesn't have all those features. So it isn't going to sound the same. So what I did was I took this flanger, and the flanger allows you to modulate the delay, but then there's the dry signal that's coming through too, and I didn't want the dry signal. I just wanted the delayed signal that you could modulate, the delay. So what I did was I took two flangers here that, and then I took a third flanger and I took the output of the third flanger in such a way that I subtracted it out of the other two, so that I was subtracting out the dry signal going through the two flangers, and all I was left with was the two signals that are modulated. And then there's the mixers and the mixer, and then I feed it back in for the feedback, and then I go forward, and then I have the dry signal comes through here like this, and I mix in the dry signal. And that's the way I ended up doing the chorus. It seems to work. I think there's a little trouble with the levels. I may have to adjust, the maximum levels, because it's easy to clip the chorus signal. Also, one thing I found on the chorus in the 4000, I actually found this in the 4000 has a bug where these delays only go up to about, I think, 92 milliseconds. They're supposed to be able to go up to like 127 milliseconds. But after you get past 92, when you go to 93, the delay goes back down to 1 millisecond. So there's something wrong with it. I don't know. I mean, that was on the 4000 itself, and mine doesn't do that, but I don't know. So it's not exactly the same in that regard. So then that's the chorus, and then it goes to the delay, which so you have these delay effects here. This delay time. You have the time, you have the dampening, which is a feedback. How much you cut back from that. And there's feedback, and the dampening is, there's the filter, and that's the dampening is in the filter. Yeah. So it has the dampening control, which is affected by this filter. And then there's the feedback. And you can set the delay and everything very similarly to the 4000. And then there's the reverb section, and there's a reverb here, this Freeverb one that does a certain amount of reverb, and you can set the reverb setup, the room size, and the amount, and the dampening. It's not quite the same controls as this dense early dampening and level. It sort of is. I mean, you can make it similar, and as long as you don't try and put too much reverb, it won't sound that different. It sounds cool. It's reverb, but it wasn't designed exactly like the way this reverb is. But for the purposes of making it sound similar enough, as long as you don't go too wild with the reverb. I've never been a big fan of too much reverb for the horn leads anyway. But there you go. So I got it as similar as I could in that way. So then after the reverb, on the Windy 1 synthesizer, there is an external input, auxiliary input, that you can mix, say, that 5000 output that I showed before in the other video. This is where that comes in. It comes in here, and you can mix it in. And then it goes over to this filter. If you wanted to make this mixer stereo, you put two of these mixers and hook them up, and then have two filters and output, and then separate left and right. You can do that if you want to change it that way. I didn't think it was necessary. A lot of times when I play the EWI, I just hook it with a monophonic output anyway, so I didn't think there was much, depending on what you want to do. So you can change that. But this filters some more filtering for this signal. Also some amount of high-pass filtering. I think the high-pass filtering is nice because when you get a large change in the filter really fast, when you're closing the filter down or opening it up really fast, sometimes you get a really big DC thump. It goes thwap. It's kind of annoying, and the 4000 doesn't have that, so it doesn't sound that way. So I adjusted this a little bit to get rid of some artifact that was occurring. Anyway, this was a tweaking item to make it sound a little bit more like the 4000 did, the dynamics of the signal coming out, particularly when the EV5000 is running through it. Okay, so that's the diagram there. Okay, so here's where you're going to find the code at GitHub, /WindySynth/Windy1. And you can download the code from here. And in here there's information about the user interface on the Windy 1 synthesizer, the knob and the screen and how it works, clicking it, etc. The diagram I was showing you here, this diagram, this code, this part of the code is all in the is actually in the code, so you can just copy the code and then import it into this from the library. So if I was to, here's the library, and there's a tutorial in here on how to use that library. So if you want to learn about that, you can learn about that there. But the code for this, that part is, this is the section here that represents that block diagram. So you can, copy this and then paste it into the tool on the import, and then it'll show you the diagram just like it shows you there. So once you download the code, there's some things to be aware of here in the code. It's a Teensy 4.1 project, and it does require that you have at least Teensy Arduino 1.54 installed. And on that other website, there's tutorials and there's information about how to get that all set up on this website, so I won't go through that. But you can download this code and get it to work as long as you have that set up properly. I have my Arduino IDE here. I've got mine set so that the text editor is using Vim because I like Vim better. But it'll still work with the other one. So there's a couple things. Once you get that installed with the Teensy Arduino 1.54, I did have to modify one of these files, this filter variable.cpp, and this describes what I did. Now, what I did was in the project, I have this file here, .text file, and you just change the name back to .cpp. Now, just remove this underscore and make it into a .cpp file, and then put it in the right spot in the library, like it describes here, in order for the filter to work properly. So once you have that all set up, then you should be able to compile the code here. And then I have a debug serial port connected up. I got one of these little modules that is a USB serial to 3.3 volt CMOS signaling scheme. And then I have that routed over to these pins right here, which is UART 8 on the Teensy Arduino. That goes over to the COM port here, and I've got this COM port set up to 1 megabit speed. And I have in the code, when you set up the serial port, I've set it to 1 megabit. I don't see any reason to go on this slower than that. There's a lot of people would just set it at 115 or something like that, 15 kilohertz or something. It just seems like slow for no reason when I'm getting all this data I need to send to the serial port very often. It's probably, at 1 megabit, it's probably too slow, really, but it seems to work good enough for my purposes. So you can play around with that. If you have your own Teensy board with just the audio shield, the serial port, you'd probably have to rig up how you'd wire to the serial port pins if you're going to use serial port 8. You could use there's another set of pins to use. Or you can try and get the serial port working through the USB, but the USB is also going to be, the USB that connects to the Teensy is also being used for the MIDI that's going to the computer when you're controlling that. So you can get it to work that way, but it's kind of a pain, and so I just moved it over to this one. I'll briefly go through the way the code is organized, if you can call it that. It's not pretty code. I just got it working. It's not like I'm some object-oriented guru or whatever. With the Arduino, it's fairly simple. You have that setup function, and then you have your main loop function, and then that's the way you go about it. Now I do have several files here. I have the Windy 1 main file, which is the show you. Yeah, it has the setup here, and then it has the loop. This is the main loop one. And then there's, at the bottom of the file, there's a couple other functions as well. EEPROM update and, read the non-position, stuff like that. So I have a state machine in here that does the graphical user interface, if you call it that, with the little screen, the little OLED screen. That's what this is that I'm showing you here. Go back up here. So basically I did this really, in my eyes, fairly simply by, I basically made a bunch of global variables at the top here that I use everywhere in various files. And I just found it easier to do this than to be passing a bunch of parameters back and forth and creating a bunch of structures when that wasn't really going to make it easier on me, since I was just doing this all myself. And it just was easy to just add all of these things in here. I did keep some of my own little naming convention here to try and remember what some of this stuff was. Back over here in this, you'll notice that if it was a DC block, I put DC in front of it. If it's a mixer, I put MIX. And if it was the waveform, I had WF mod, and if it was a multiplier, I put mult. So the objects here were easier for me to find where everything was. And then I did have some structures that I needed to build for the patches. Let me see. These are all the parameters. For example, the patch synth variables. So you have to have all of these variables that get tied from the patch, and they need to be floating point numbers for the floating point math, and then comes over in the MIDI in some number between 0 and 127, and then it gets scaled, however it gets scaled, to make these numbers. And so these are a lot of those numbers. And then when you set this up, the setup here, you can see I set some pin modes. This is, never mind this. This is old. I had a, in an older design, I had push buttons to go next on the patch and things like that. So that button is no longer there. For the knob, though, you push the knob and move the knob, and that's how you do the user interface now. And here's my serial 8 at 1 megabit, like I talked about before. There's an SD card that you can write to and read from. That's where the patches are stored. This is the audio chip that you enable and set to a certain the settings for. And then there's the memory that you need for the audio stuff. You have to give it a certain number of blocks that it's going to be able to use. Some of these settings are for the input and output levels here to get it started of the audio chip. So there's a whole bunch of parameters in here that get set up, and this is the setup for it. I won't go through all of these, but you can see that the design has quite a bit of parameters that have to get set up and things that have to get ready before you even do anything. So this has got a USB host controller on it, so that's how it's able to use, like with the USB, the EWI USB, it plugs into this, and this synthesizer hosts the EWI USB, which is really nice. I like that. And then it'll host the EWI 5000 as well, so you don't need a computer, in between or whatever. So that's really nice. But it also has the other USB connection, which is connected to the Teensy, which is how you communicate with the Vyzex tool, this tool down here. And this is this Vyzex tool communicates through the MIDI ports here, see, and then you got to do the other one. And you can see that debug UART, they're spitting out all the information it's communicating with. So, and then you make sure these are connected to the Windy as well. You want to pick the right one there. Okay. And then when you pick a set like that, it's going to send at least the one buffer it's on to the synthesizer. So if I select that one, then it just refreshed all of the sounds over, all of the parameters over here. You can see it spits them all. That's the patch right there. This sysx message was all the patch information, and then I spew out what all the numbers are so I could see if I was getting them converted right. So like I said, that's the other USB. So there's two USBs to get started here. There's a double EEPROM on here. It's not really a double EEPROM, but it works like a double EEPROM. I guess it's a flash chip that they've, made it work like a double EEPROM, I guess, which is good enough for what I need to do. And it's going to load the patches, which patch, and the information, as well as some of the other settings that are like the transpose setting and some of that stuff. Then the main loop. The main loop is basically set up. So this part is just going to read the knob every so often to make sure it's set up to every so many milliseconds. Read the knob and make sure that the UI is handled, and that's what this is. Also, there's a timeout here if the UI has been changed, and then it waits a while, and then if it times out, then it's going to write what the changes are, like which patch you have selected and the other information, the transpose and some of those other things, mixed value, etc. It writes those to the double EEPROM, but it only writes values that are changed, so it doesn't always write. And then it waits a while before it does the write, so that if you're changing a whole bunch of things in a row, it doesn't save every one of them. When you need to update the values of the synthesizer because you've made some modification, changing a patch or whatever, or changing a value through the editor software, you need to update the synthesizer values. It comes in here, and this flag gets set, and it comes in here and updates all of these different parameters of the synthesizer. And those don't have to be updated necessarily without the interrupts on, because you're just changing the values, those ones. But then there's some values that you want them to change all at the same time. So then you turn this interrupts off, basically these audio interrupts off, and change all the values and then turn it back on. So there's some changing of what happens here, quite a few values. And then this is processing the MIDI, the incoming MIDI host from the host. This is coming from the EWI. It processes the MIDI there, and then this one is processing the MIDI that goes to the Teensy, which is from the editor. So that's what this processMIDI does. So there's two different processes that happen. This one happens an update. The breath controller's changing all the time, the pitch bend's changing all the time, which notes are happening, that kind of stuff. And then this one down here is changing the parameters as you're changing in the editor, for example. And then again, this is just EEPROM update stuff. That's what that is. And then there's some helper functions I created that do some of the various things here. That's the main function. There's some more files in here. This one is there's a header file that has a bunch of constants in it. The patches file, when there's some parameter that gets updated, it comes in here, and each one of these parameters that gets sent over from the editor, for example, or when you update a patch because you just changed the knob and it moves the patch, all of these parameters that are stored, these values that are between 0 and 127, have to get converted to what value they needed for the synthesizer, and that's what this does. This function does that for all of these parameters. And then there's a print of the values, and that's what you see over there in the COM port. And there's some more handling of the patches, and this is the SD card access. So this is doing some of this stuff. Like, again, this file is called patches.ino, but there's stuff in here about the SD card, and so it's not organized that well, but hopefully you can follow it if you need to, just to see kind of how I did things, and then you can rewrite it however you want. And this is the MIDI processing section. So there's this particular one processes the messages that come in from the editor. So each of them have each of those knobs and things. There's a section, sort of a section. There's an oscillator section for the Oscillator 1, and it has a whole section of things that can happen, and then Oscillator 2, and so that's what they're arranged that way. And then this is the USB MIDI. So this is the stuff that comes in from the editor coming in here. So that's what all this stuff is. And then there's the sysx commands, which is also from the editor. Yeah, that's right, because the other one has the... So this one is actually in the main file, the one that processes the file. This is the one that processes the breath controller. So there's a whole bunch of math going on when you change the breath happens, or when a node on happens, or it doesn't happen. And is the node on is it a brand new note on there was no notes on before, or is it legato where the note is coming on while there was already a note on? So that logic's handled in here, and what happens with everything is in all of this. It handles pitch bend, the note off, obviously, and you would handle anything you wanted to add in here as well. There's a callback method of using MIDI, and I tried it, and I didn't think it worked very well. I think that it was a little slow, and I don't know, maybe I didn't do it right or something, but I tried it and I didn't like it, so I put it back to this method, and it seems to work pretty well. So like I said, it could be organized better, but at least it does what I wanted it to do, which was to mimic the 4000, and I got it pretty close. Anyway, there you go. That's the code for the Windy One synthesizer. I'm going to probably build my own synthesizer now that I know how to do this, and build another editor or whatever so that I can edit that, because there's a lot I like about the 4000 and it sounds, but there's some things it doesn't do that I would like to make it do. So I'll probably be doing that, and if I end up doing that, I'll share that here. So let me know what you think, and in the comments below, let me know if there's something you want to see more detail on, or if you have any questions about it. And if you like this video and you want to see more like this, go ahead and click the like. Thanks a lot.